The great expert on swept wings in pre-war was Professor Buseman of the research establishment at Focke-Wulf.
1944. A four-engined powerhouse flies through the clear skies over Kansas. The Boeing B-29 is ready to join the war after a lengthy and troubled development that began in late 1939. With 1250 caliber Browning machine guns and a standard loadout of 20,000 pounds of bombs, it truly lives up to its nickname, the Superfortress. Designed as a high-altitude daytime bomber, it is intended to be used in the Pacific theater of the war. The finished planes are flown from the Boeing plant in Wichita, Kansas, to the eastern tip of North America in Newfoundland, across the Atlantic Ocean to Morocco, to Iran in the Middle East, and finally to India, where they will be stationed for several months. From here, they can be sent to China, where they will be within striking distance of the home islands of Japan, which have been free from direct attacks since the Doolittle Raid of 1942. But one of these bombers has a different fate. Its mission is not one of destruction, but of deception. It is flown from Kansas to Newfoundland and across the Atlantic. As its fellow B-29s are striking targets in Asia, first Bangkok's railroad shops, then the Imperial Iron and Steel Works of Japan, this one is headed for England. Instead of arriving under the cover of night, it arrives in broad daylight at RAF Bovington, northwest of London. Landing before a crowd of onlookers, it is driven up and down the runway, a show of the Allies' latest marvel of the air. And the crowds are impressed indeed. The B-29 is one of the largest aircraft ever built, at a length of 99 feet and a wingspan of 141 feet. But one of these onlookers isn't there to appreciate America's latest technological achievement. Returning home, the man is careful to conceal what he is about to do. Retrieving a straight key transmitter from a hidden location, he prepares to send a signal across the Channel to Europe. There, an operator receives the message and decodes the warning about this new threat, passing the valuable information on to the headquarters of the German Air Ministry. And this is exactly the scenario the Allies have been counting on. With good knowledge of where spies in England are located, it is known that this information will be sent on to their enemy. With the war dramatically turning against them, the notion of even heavier bombing is a frightening prospect for Germany. The US Air Force's Big Week offensive in late February of 1944 had the Americans flying heavily escorted bombing missions against airframe manufacturing and assembly plants around Germany. The results have been devastating, with the Luftwaffe losing close to 100 of their fighter pilots. Panic is rising all around, and this information is making matters much worse. The Americans have leaked enough information about the new bomber for the Germans to know just how much of a threat they are facing. If the B-29 is to be used in Europe, Germany will need to form a defensive strategy to shoot them down, and this poses a problem. The B-29, with its pressurized cabin, can fly at an incredible altitude of 40,000 feet. Though some of the German army's more powerful artillery can fire to that height, the bombers will be almost impossible to hit. And as Germany has not yet developed proximity fuses, it will prove a challenge for their defences. If B-29s do appear in the skies over Germany, they need to be brought down by other methods. With the recent development of the turbojet engine, Germany now has fighter aircraft that can fly at incredible speeds. But will that be enough to combat the threat of the B-29? The Messerschmitt Me-262 is Germany's latest jet aircraft. Powered by two Junkers Jumo 004 engines, it is a deadly adversary for Allied aircraft.
Right, now the Me-262 was, in my opinion, I've stated this many times, the most formidable aircraft of World War II. When you consider that at the end of the war, the top Allied fighter was the Spitfire Mark 14 with a top speed of 446 miles an hour. When we tested the Messerschmitt 262, it had a top speed of 568 miles an hour. This was a quantum jump in performance, and it meant the 262 was virtually inviolate.
Originally straight-winged, the production version of the 262 has wings swept at an angle of 18.5 degrees. This is done to adjust the aircraft's centre of gravity when the engine proved to be heavier than originally expected.
It had one shortcoming, but then I would say two shortcomings, but all the early jets did in our country, in America and in Germany. Firstly, the engines were very sensitive. They were slow to accelerate to throttle movement, and you had to handle them very carefully to avoid flaming them out. Secondly, we hadn't thought, or the designers hadn't thought, of how to slow down these incredibly fast airplanes, and no air brakes were fitted. And this made life very difficult, for example, for landing.
The 262's standard tactic against bomber formations approaching from a higher altitude and then diving down to their level and opening fire will not be effective against this new enemy. The 262 only holds enough fuel for approximately 1 hour in the air. It takes close to 15 minutes for the aircraft to reach its maximum altitude, not including the time it needs to locate its targets, which eats up plenty of fuel. Experiments are undertaken to see if this problem can be overcome. In one case, a rocket engine is added to a 262 to provide a boost during climbs. Another idea proposed to increase the plane's rate of climb is to mount ramjets on its wings. And while the ramjets will provide more thrust, their added weight would slow the aircraft down in level flight and deplete even more fuel. Tweaking the Me-262 is not the answer the Air Ministry is looking for. However, Germany also has a light fighter in development, the Heinkel 162. As raw materials and qualified pilots are becoming scarce, a cheap-to-produce and easy-to-replace plane is appealing. Officially named Volksjäger or People's Fighter, it is also known as the Salamander. Constructed primarily of wood, it is roughly half the weight of other fighters and houses a BMW 003 engine in a nacelle mounted on top of the fuselage.
The Heinkel 162 was certainly an intriguing idea. It was a well-designed aircraft. The catch is the Germans were running out of time. They were planning to use teenagers out of the Hitler Youth or out of the National Socialist Flying Corps, which at least had some basic training on gliders. Train all these youngsters on gliders and put them on single-seat jet fighters, because there was no two-seat version of this thing, and hope for the best. Keeping in mind you had to produce these things. Again, you need the resources, you need the fuel, you need the workers. It was not an aircraft for the uninitiated. It was a jet aircraft, after all, a very high-performance machine. So put inexperienced pilots in a fairly hot machine with lots of Allied aircraft buzzing all around was not a good idea.
And despite its lightweight and high speed, the Salamander has even less endurance in the air than the Me-262, and so won't be able to combat the B-29 effectively. Several technical hurdles still need to be overcome before the next generation of German jet aircraft can take to the sky. In England, Frank Whittle's centrifugal jet engine has proved to be very reliable, able to endure over 100 hours of flying time before requiring repairs. But that reliability comes at the cost of speed. The Junkers and BMW axial flow engines, while much faster than anything the Allies have, are complicated to produce and last no longer than 12 hours in the air before a full retrofit is needed, and a total of only 25 hours until they need to be replaced. But new engine developments are on the way for Germany, courtesy of Heinkel-Hurth, the HES 011 turbojet engine. Featuring a unique combination of the axial and centrifugal compressors, it promises to be easier to produce and more reliable than the other German engines.
All German project development in the latter months of the war were all based around the HES 011 engines, but then there were many other manufacturers, engine manufacturers, who were actually developing even more powerful engines, and some of today modern day airliner engines today can actually be traced back to some of those ideas.
After the First World War, Germany had been forbidden from developing military aircraft technology, but they were not stopped from the development of all technologies related to flight. So while aircraft makers in the rest of the world were working to improve the performance of powered aircraft, the Germans were designing gliders, with many engineers taking a keen interest in aerodynamics and how to use the natural forces in the atmosphere to fly further and faster. The development of the modern wind tunnel by Ludwig Prandtl opened new horizons for the testing of how various shapes dealt with airflow. As war loomed once more, there arose a need for faster aircraft, and the proliferation of wind tunnels across Germany would help in the testing of new designs. So the development of the high-speed jet engine is identifying problems that had only been seen in wind tunnels before, that straight wings lose stability just above and below the speed of sound, in what is known as the transonic region. But in theory, a swept wing will lessen the drag caused by the formation of shock waves as airflow wraps around the wings.
The great expert on swept wings in pre-war was Professor Busemann of the research establishment at Focke-Wulf. And he gave an open forum lecture in Rome in 1935. And he put forward that sweeping the wings back doesn't mean you can go supersonic. What it does do is it smooths the transition from transonic flight to supersonic flight by reducing the compressibility effects. So it's a great aid on the way to supersonic flight, but it is not the key to supersonic flight.
Despite the fact that many leading aircraft experts of the day had attended the Volta conference in Rome and seen Adolf Busemann's presentation on swept wings, it was considered little more than an academic curiosity. As the airspeed record of 1935 had only been 440 miles per hour, the notion of supersonic flight seemed a very long way off. By the time World War II breaks out, Busemann's theories are all but forgotten. He conducts experimental wind tunnel tests of his theories, and by 1942 has amassed a considerable amount of technical data. Now, as planes on all sides are becoming faster and reaching the transonic region, they are witnessing the dangers that compressibility effects have on aircraft. Buseman's theories can finally come to the fore. Knowing that they have the technological advancements required to combat the B-29, Germany now needs an aircraft to house them. On July the 15th, 1944, just over a month after the D-Day landings, the Luftwaffe decides to halt all production of bombers and multi-role aircraft. Defense is now the name of the game. Calls go out to the top German aircraft manufacturers for an emergency fighter, a jet aircraft that can take on the threat posed by new Allied fighters and the American Superfortress. At Messerschmitt, preliminary plans for a new fighter are drawn up. This aircraft, designated P-1101, will have a short, wide fuselage and tricycle landing gears. Willy Messerschmitt is curious about the benefit of swept wings, having researched the topic since 1940. Wind tunnel tests on models with various wing and fuselage profiles are conducted, and the differing results that each swept wing profile returns is intriguing. As many components have already been built, it is decided that the best way to get accurate test results is to build a prototype aircraft. Without the official backing of the German Air Ministry, Messerschmitt goes ahead and begins construction. It is given a mechanism that allows the wing sweep to be adjusted on the ground from 30 to 40 to 45 degrees. Other aircraft firms also submit designs for an emergency fighter. At Focke-Wulf, head designer Kurt Tank believes his team has some advantages over the competition. His FW-190 is already a workhorse for the Luftwaffe, with over 20,000 produced.
Kurt Tank was a brilliant designer, but he was also his company's assistant chief test pilot. And he had this huge advantage of knowing how to fly the airplane, and even was prepared to fly it in combat. When he flew from Bremen, whenever he was up, he would look around to see if there was any chance of getting a combat, and he was a remarkable man. He just thirsted for knowledge.
In March of 1943, one of Tank's team at Focke-Wulf had begun work on a series of design studies for a single-seat jet-engined aircraft. The man behind the designs is engineer Hans Multop. Multop had studied under Ludwig Prandtl at the University of Göttingen, where he wrote a thesis on the lift theory of wings. In 1938, Kurt Tank brought him to Focke-Wulf to work as his assistant in the Department of Developmental Aerodynamics, and by 1943, Multop had gone on to become a chief designer. Operating under the theory that the longer the distance the air must travel before it reaches the engine, the less power it will have, the Flitzer, or Madcap, is designed around a very short fuselage, with its jet intakes located at the wing roots. Its wings have a leading-edge sweep of 32 degrees. A twin boom holds the tailplane above and out of the way of the exhaust from its single HES-011 engine. The jet propulsion is to be supplemented with a Walters liquid propellant rocket engine, but it is removed from the final designs. Curiously, the Flitzer's design is very similar to that of the Vampire, another aircraft being developed in England around the same time. It is the second jet aircraft to be commissioned by the RAF. Both the Flitzer and the Vampire are single jet-engined aircraft with a short fuselage and twin booms supporting the tailplane. This coincidence comes about not through espionage, but simply the common logic of creating a jet fighter with a single engine for better fuel economy, and to provide centerline thrust. The Flitzer is well along in development, with a full-size mock-up and some prototype sub-assemblies completed. But despite the progress, the project is abandoned, because the plane's performance is expected to be no better than that of the Me-262. But when the emergency fighter program is announced, Hans Multop already has all the experience and knowledge gained from developing the Flitzer to work from. His next design, the TA-183 Huckebein, will be the culmination of aerodynamic research that his team began in 1942. And one of the major new steps implemented will be the use of fully swept wings. Taking its name from a mischievous cartoon raven, the Huckebein has wings mounted in the middle of its short fuselage and swept back at 40 degrees. It has a pressurized cockpit with a bubble canopy providing excellent all-round vision. The Huckebein's fin is very long and tall, putting the tailplane above the flow of the air as it wraps around the wings, lessening the amount of turbulence. The first design uses a T-tail sitting at the end of a long vertical stabilizer swept back at an angle of 60 degrees. As tests progress, the T-tail gives way to a V-shape that is bent slightly upwards. It is intended that the plane will use the HES-011 jet engine. However, prototypes will use the same Junkers UMO 004 engine found in the ME-262. And, like the Flitzer before it, early studies for the aircraft call for it to be equipped with a rocket engine, with enough fuel located in underwing drop tanks for a 200-second rocket burn. But again, the rocket engine is removed before designs move forward. A single jet engine will propel the Huckebein, giving it more range and better fuel economy than the two-engined ME-262. Expected to be able to fly at speeds of 1,000 kilometers per hour and up to an altitude of 45,000 feet, the Huckebein will swoop down from above and blast the bombers with its 4 30mm cannons. But will cannons alone be enough? The B-29's revolutionary central fire control system allows the gunners to direct 4 remote-controlled turrets, each armed with 2 50-caliber machine guns through the use of analog computers. Highly advanced for their time, the General Electric designed computers correct for airspeed, target speed, and other factors that can hinder the gunner's accuracy. These improvements make it dangerous for fighters to get too close to the B-29. To combat this, Germany needs an advanced weapon of their own. At the Ruhrstahl Company in Düsseldorf, Dr. Max Kramer is working on just such a weapon. His goal is to build a missile with enough range to allow it to be fired from well out of reach of the bomber's guns, while being guided with enough accuracy to hit its intended target.
During the Second World War, there was a lot of work being done on surface-to-air anti-aircraft missiles, guided weapons of various types. There was a bewildering variety of types that the Germans worked on. Not all of them very practical, mind you, but a lot of variety. They were also involved in early designs of air-to-air missiles. I know of one, which doesn't mean there were not more than one. I know of one, the X-4. Fairly small weapon, again, air-to-air. You wanted to use something that was tiny, just by Second World War standards, something you could almost hold in your arms. It is the ancestor of the modern air-to-air missile.
The X-4 is guided by signals sent via thin wires that run back to its guidance mechanism on the aircraft. As the missile flies, the wire is reeled out behind it. A small joystick in the plane's cockpit allows the pilot to guide the direction of the missile. That, as well as having enough rocket power to fly for 3.5 miles, makes it the ideal weapon for staying out of range of the B-29's guns. But because it is so difficult for the pilot to judge the distance to the target aircraft from so far back, the missile is armed with a newly developed acoustic-based proximity fuse, known as the Kranich. As the X-4 project is well known to aircraft engineers, the Huckebein is designed with the missile specifications and requirements in mind, possibly making it the first instance of a complete weapons system. On February the 28th, 1945, the Luftwaffe High Command examines the emergency fighter proposals and selects a design by Junkers to be developed and produced. The Huckebein comes in second place. But before long it is decided that the Huckebein is a better design, and Kurt Tank is told to plan for full production. Flight tests are scheduled for May of 1945 and 16 prototypes are to be built. Then, on April the 8th, British troops capture the Focke-Wulf facilities, ending any chance that the TA-183 Huckebein will see the prototype stage. The HES 011 engine, still delayed, never makes it into mass production. By the end of the war, only 19 engines have been built. In the months following the war, agents from Allied countries scour Europe for designs and ideas that can be used by their country's aircraft industry.
There were so many projects produced and so many projects found at various aircraft manufacturers that the Allies really didn't know what was actually worth pursuing and what wasn't. And a lot of the Allied aircraft engineers thought that some of this stuff was pie in the sky anyway, and thought that, well, you know, we know what we're doing and we're going to do it our way, which actually was not a very good idea, because the Germans were a long way advanced on their high-speed development of bombers and aeroplanes, unconventional designs.
Adolf Busemann is visited by a group of American scientists at his lab in Braunschweig, some of whom had attended the Volta Conference in 1935, but had overlooked his research then. It is only now that the Western Allies begin to see the potential of swept wings. The B-47 Stratojet, in development as a straight-winged bomber, is given swept wings when Boeing's chief aerodynamicist relays the information back to the United States. At North American Aviation, the wings of FJ Fury fighter jet receive a 35-degree sweep before going into production as the F-86 Sabre. After the war, Hans Multop moves to the United States as part of Operation Paperclip, under which the US intelligence and military extract scientists from Nazi Germany. Working for the Martin Company, his knowledge of swept-wing designs contributes to later versions of the F-84 and the F-86 Sabre, as well as the experimental X-24 lifting bodyplane. Kurt Tank is offered a job at the Aerotechnical Institute in Cordoba, Argentina, by Juan Perón's government. The ideas behind the Huckebein lift off again as he gathers a team from the Focke-Wulf Design Bureau. As the HES 011 engine is no longer in development, it is replaced with one by Rolls-Royce, the Nien 2. The fuselage is widened to accommodate this larger centrifugal engine. The wings are mounted higher up on the fuselage as compared to the Huckebein. The new aircraft is named the Pulki II. Test flights begin on June the 16th, 1950. The plane reaches the incredible speed of 1,000 kilometers per hour. But as promising as that is, there are other problems. Pilots find the aircraft very difficult to handle, and 2 are killed during test flights. And those are not the only problems Kurt Tank faces. An economic crisis hits Argentina in 1953. The pricey Pulki II project is halted, temporarily at first, but in 1955 Juan Perón's government falls, dealing Tank's team another blow. Soon after, the availability of cheap F-86 Sabres makes the development of a homegrown fighter a needless luxury for Argentina. It is not only the Western Allies who benefit from the work of German aviation experts. In the dwindling days of the war, Soviet forces discover the Huckebein's plans and several prototypes, which are transported back to Russia. Because of this, it is often thought that the Huckebein may have inspired the fabled MiG-15, an aircraft that rivaled the Sabre. And although the MiG-15 and the Huckebein share a number of similarities, such as swept wings, a high rate of climb, an elongated tail fin, this theory has been discredited. The majority of Focke-Wulf's engineers were taken in by the Western Allies. However, as the Soviets had possession of the German Air Ministry, the central repository for all Germany's aviation ideas, they did have all the technical data and designs dealing with swept-wing aircraft, which would have provided them the proof that swept wings were a good avenue to follow. That single B-29 landing in England set in motion events that would be felt for years to come. While it did have the intended consequences of surprising the Germans and forcing them to pour their already thin resources into the development of another new aircraft, it also laid the groundwork for swept wings to be adopted earlier than had the need for an emergency fighter not been so dire. And while the implementation of sweep theory is a boon to aviation progress, it will come back to haunt the United States in the years to come, when the MiG-15 appears in the skies over Korea.
In 1951, a Mikhail Gordievich MiG-15 is shot down over Korea's west coast and plummets into the Yellow Sea. The jet is pulled from the shallow water by US and South Korean forces, transported by a British frigate for study. At a US Air Force base in Dayton, Ohio, the plane is pored over. One of the first discoveries of this incredible aircraft comes when the engine is inspected. Expecting to find a hybrid of Russian and German jet technology, the team studying the captured prize receive a shock. The plane is powered by what appears to be a Rolls-Royce Nene 2, designed in England. 1940. Since the signing of the Molotov-Ribbentrop Pact, Germany and the Soviet Union have been in an alliance, using their combined might to carve up Eastern Europe. With France giving in quickly to the Nazis, England's newly appointed Prime Minister, Winston Churchill, knows that German troops will soon be clambering up the English beachfront. He decides to send a new ambassador to Moscow, and a member of Parliament volunteers for the job. He is Richard Stafford Cripps. Born into privilege, Cripps' first love is chemistry, and following a stint as an ambulance driver during the Great War, he studies law and becomes a successful attorney, before an interest in politics lures him to run for office. Cripps joins the Labour Party, and in 1930 becomes Solicitor General in Ramsay MacDonald's government, a position that includes the honour of becoming a knight. Though regarded by all as a brilliant man, Sir Stafford Cripps has a tendency to ruffle feathers, and soon finds himself clashing with Labour over his political leanings. Some of his views are considered so extremely left-wing by the Labour Party that he's chased out. Now sitting as an independent, he finds himself on a trip to Moscow, with a goal of aligning the Soviet Union with Britain.
Stafford Cripps was certainly born into a life of privilege, and his father was a Conservative MP. This no doubt stimulated his own interest in politics. But what I think really led him into his own particular line in politics was really his religion. We can't understand Stafford Cripps unless we understand that he was a committed Christian who had very fervent beliefs. In some ways they seem rather naive. They're certainly idealistic. He believed in the brotherhood of man. The crucial event for him was really the economic crisis of 1931, when Britain was hit by the so-called economic blizzard that swept away the Labour government and seemed to indicate that the capitalist system simply wasn't coping and couldn't cope. This led Cripps from being a moderate member of the Labour Party into adopting Marxism, which naturally involved a degree of sympathy with the Soviet Union.
In 1940, while the Battle of Britain rages, Cripps arrives in Moscow. While hope is high that he can steer Russia into an alliance with England, early results are not at all promising. Just days after Cripps has a 3-hour meeting with Joseph Stalin, the Soviet Premier and Foreign Commissar Vyacheslav Molotov gives a speech on how successful the Russian-German alliance has been for the country. Cripps continually warns Stalin not to trust Hitler, but to no avail.
The key episode was really from 1940 to 1941, when he went to Russia as Britain's ambassador. And what he found there certainly changed his view and formed what to many people will seem a surprisingly unfavourable view of Soviet Russia for such a left-wing figure.
From his book, the Cripps version, Dr. Peter Clark reads Cripps' correspondence with his daughter during the politician's time as ambassador in Russia.
He's talking about the regime and says that it has many difficulties, perhaps due partly because they're inherent in every form of dictatorship. And he continues in this way: if to all these difficulties you add the government by secret police and spies, which is the only method for a dictatorship, then in such a country as this, with a people of this kind apt to intrigue and brought up in underground revolutionary activities, you get perpetual change of personnel and liquidation of many of the more intelligent people, creating new difficulties of organisation. In the passage I just quoted, we see already, surely, that Cripps accepts that this is essentially a dictatorship, it is essentially a police state, that it is in many ways a deeply unattractive society. During the war, admittedly, he argued very strongly in favour of alliance with Russia as the best way to beat Hitler's Germany. But long before the end of the war, he was certainly no ideological captive of the communist system.
Within a year, Cripps' warnings about Hitler's trustworthiness become all too real, and Stalin must face the awful truth. Operation Barbarossa begins as Nazi Germany storms into Soviet-controlled territory and pushes Stalin's forces back. It's a swift, fiery onslaught that knocks the Red Army back on its heels. It's a turn of events which suits Winston Churchill just fine. Not only does this new Eastern Front relieve some of the pressure on his troops, but it gives him, and particularly Cripps, clout with Stalin and amongst the Russians. A bond is forged over their common enemy, and soon an Anglo-Russian alliance is formed. But Churchill may be on shaky ground at home. Not only do the Russian politicians embrace Cripps, but the British public do as well. After a broadcast to the nation on the situation in Russia, Cripps is suddenly one of the most popular men in the nation, even seen as a contender for the position of Prime Minister. At a time when defeats are plentiful, Cripps makes it known that he'd be ready to take up the post if Churchill is unable to manage. Churchill seizes on this. In March of 1942, he sends his new rival to India in order to broker a deal with Gandhi and Jinnah. If the Cripps mission is a success, India will aid the war effort against the Nazis in exchange for self-rule once the conflict is at an end. But the mixed messages Cripps seems to be giving to the Indian negotiators during the trip causes it to end with no deal in place. The Indian Congress Party will not agree to aid England in the war. But aid is coming from another source. Through its Lend-Lease program, the United States of America begins to send supplies to the Allied forces in exchange for gold. They supply vast numbers of vehicles throughout the war, and Britain is the main beneficiary of the deal. The Soviet Union is far behind the West in technological advances, and needs aid as well. Russia receives close to 15,000 aircraft by the war's end, almost 20% of all the aircraft that they use. The most prominent of these is the Bell P-39 Airacobra. It's best suited for low-altitude flight due to its lack of turbo superchargers. Its unconventional layout, with the engine behind the pilot, leaves little room for storing fuel. The standard load is carried in the P-39's wings. It's therefore limited to short-range tactical strikes. The most advanced fighters and bombers the Americans keep for themselves. It aggravates the Soviets to be given the older technology, but they make do with what they're given. Of the equipment delivered, much of it is not suited to combat on the Eastern Front. Aircraft meant for tropical conditions are now used in a much colder climate. There are few spare parts, and so crews must sometimes improvise as best they can. The Soviets learned to adapt the Western technology to their needs and uses, skills that will serve them well in the years to come. 1945. First, Nazi Germany falls, and then so does Winston Churchill. The general election on July the 5th knocks the Conservatives from power and brings in a new Labour government, led by the wartime coalition government's Deputy Prime Minister, Clement Attlee. The public feels that the Labour Party will be more adept at helping England rebuild in the post-war period. Joining Attlee's cabinet as Minister of the Board of Trade is Sir Stafford Cripps.
The election of a Labour government in 1945 came as a great surprise to the world, who imagined that Winston Churchill would inevitably win re-election, having won the war. I think it's important to realise the strong elements of continuity, especially in foreign policy, that went over from Churchill's coalition wartime government, in which Labour had played a big part, into the post-war Labour government.
The main thrust of this new government is to rebuild the war-weathered country. It's about winning the peace by giving Britons a crutch to lean on. They use the 1942 Beveridge Report as a guide for reforming the country. Attlee brings about sweeping changes that will alter the country for decades to come. Free national health care, education for everyone up to the age of 15, social security. He works towards giving India and Burma their freedom. It's far removed from the direction that their ally America is heading. More and more nations adopt communism, and never comfortable with these ideals, America finds these new social developments within Britain curious and worrisome. Churchill was the sort of man Americans understood, and Attlee is no Churchill. He's small and modest, spares his words when they aren't needed. To Americans, the contrast is a sharp one that gives them pause. Labour's domestic policies seem much closer to communism than to capitalism.
Foreign policy was largely in the hands of the Prime Minister, Clement Attlee, and the very strong Foreign Secretary, Ernest Bevin. Now, both of them, in 1945 and 1946, were ready to take a much stronger line against the Soviet Union and its threat to the integrity of states in Eastern Europe than the Americans were at the time. So Attlee and Bevin had to argue with President Truman about the need to stand up to Soviet Russia. It wasn't really until events took their own course during 1946 that, in a sense, Truman came round to the rather harder line that the British government was already following. It's therefore somewhat surprising to find that in popular politics in the United States, Britain, simply because it had a Labour government, was then perceived as a weak link in the Western alliance. If you come down to the realities of the situation, you see that it's in fact British policy that is actually more consistent through the 1940s in taking a firm line in opposing Soviet expansionism. And Cripps, for all his previous sympathy with the Soviet Union, is firmly in support of the line of the government of which he's a leading member.
America's astounding capacity for production kept Britain well supplied during its darkest days following the Battle of Britain and supplemented their renewed manufacturing throughout the rest of the war. And now, very suddenly, the Lend-Lease program, that boon to Allied nations throughout the war, ends. America turns off the tap and stops the flow of resources into Britain. Not only that, they send the bill. Over £1 billion to be paid back over a 50-year period. As America is entering a post-war boom in prosperity, Britain is withering under its immense debt and damaged infrastructure. 750,000 homes damaged or destroyed. 1/3 of gold reserves spent. Food rationing becomes more stringent than it had been during the war. Coal, an absolute necessity for providing Britain with heat and manufacturing, is scarce.
We shall only get it right if we can produce much more than we did before the war. That's the only way we can get the things we need. Food, clothes, entertainment, a little less struggle to live, a decent home and warmth. We want colour in our lives, A better education for the kids, bigger pensions for the old people, and all the rest. No doubt we're in a bit of a tough spot, and it'll take a year or two to get out. But we've done it before, and we can do it again.
And while the post-war situation is tumultuous for the common people, it's a windfall for the Allied militaries. Germany's defeat sees its treasure trove of technological secrets scatter for anyone looking to pick up the pieces. The Allied nations rush into German territory to recruit the top scientists and to integrate these advancements into their own country's technology. Russian forces lay their hands on the Reich Air Ministry in Berlin and the many secrets within it. Swept wings, rocket power, and the jet engine. With this information, they can make a vast leap ahead and finally begin to catch up to the Western powers. And since the pre-war days, when Stalin assessed his nation to be 50 to 100 years behind Western technology, the Soviet Union has been making great advancements. One Soviet manufacturer, the Mikoyan Guryevich Design Bureau, has been creating aircraft since 1940, establishing a solid reputation for creating fighter planes. Their first post-war design, the MiG-9, is powered by a copy of the captured German BMW 003 engine. As early jets go, it has a fairly conventional design, an all-metal fuselage with straight wings. For their second-generation jet aircraft, they'll be incorporating some new ideas in aerodynamics. But for all the advancements that they'd like to implement, the power plant is not up to snuff. The German jet engine that the Russians discover has its flaws. The axial flow system, while powerful, is difficult to maintain. Engines quickly burn out and must be replaced. Their short lifespans plagued German ground crews throughout the war, and though the Soviets pursue the creation of their own jet engine based on this technology, they find themselves facing the very same problems the Germans had. Germany's most advanced jet engine design is proving difficult to perfect. The new airframe designs that Mikoyan Guryevich are creating will need something more advanced and reliable than the adapted German engine. To keep up with Western development, Russia will need a centrifugal flow jet engine, like Frank Whittle has developed in England. While not as powerful as the axial engine, it's reliable and has been a proven performer. Rolls-Royce has continued to make developments using Whittle's ideas, and currently have the Neen 2 engine, which, despite its great power, has only thus far been used in prototypes of the Hawker Seahawk and the failed Supermarine Attacker. Without an advanced jet engine, Russia's aircraft development will be at a standstill. The Soviet aviation minister Mikhail Khrunichev and designer Alexander Yakovlev suggest to Stalin that they purchase more advanced engines from another country. Stalin scoffs at Khrunichev's idea. What fool will sell us his secrets, he asks. Despite knowing that his men will fail on their journey to purchase this technology, Stalin allows the trade mission to go ahead. MiG's Artem Mikoyan, engine designer Vladimir Klimov and others travel to England to tour Rolls-Royce's plant and to see other British aircraft developments. When the trade mission lands in London, they find a socialist government ready to embrace them. There's still much goodwill afforded to Russia, still seen by British eyes as an ally in the noble war against Nazi forces. That, and post-war England needs money. The Soviet delegation tours the Rolls-Royce plant and are shown their latest engine developments, the Derwent and the Neen. They ask to purchase several of each. When the order comes across the desk of a Ministry of Supply employee, he warns Minister John Wilmot against selling the Soviets the technology. Britain is the absolute leader in jet engines. Russia is at least 5 years away from similar developments. Selling them one of the nation's greatest achievements would be, as Stalin has said, foolish. But the sale is pushed through by the President of the Board of Trade, Sir Stafford Cripps.
I think it was a socialist move to a socialist government, or an extreme Soviet government. We'd helped the Soviets before, or the Stalinists before, of course, at the beginning of World War II. But here I think this was going beyond the call of duty after the end of the war. And it certainly hurled them straight into the Premier League in aviation.
Despite a distrust of Stalin after his time in Moscow, Cripps sees the world breaking into two spheres of influence and wants to bring those sides together. Not only that, the sale means a good deal of money for Rolls-Royce at a time when big contracts are hard to come by. Cripps even offers to allow the Soviets to build the engine themselves under license.
The circumstances of the sale of the Rolls-Royce engines to Russia can't be divorced from Britain's economic predicament after the war, with a desperate need to increase exports. Cripps, as President of the Board of Trade, was the minister with primary responsibility for British trade. It's only natural, therefore, that he should have wanted to encourage expansion of British trade and opportunities for British exports in every direction possible. And certainly in 1946, he was taking the view that Russia was a promising export market as far as British manufacturers were concerned. I think it's only natural, given all the circumstances, that he would have wanted to approve the sale of aircraft engines, which, after all, at that time, were not regarded as classified or restricted, had not been put under any sort of military ban. And there's frankly no need to seek further for an ideological explanation of his decision to approve a deal that he saw simply as being in the British national interest in order to revive British trade.
While Cripps' actions on the sale may have been honest, the Soviet delegations are less so. Rather than accepting the license, the Russian engine manufacturer Klimov begins to reverse engineer the Nien from the examples they've purchased. The Russians begin producing a version, the Klimov RD-45. But creating a successful engine is proving difficult. England has a long history of metallurgy dating back centuries. Small forges all over the British Isles have developed techniques to create strong metals from ores and minerals found throughout the empire that are perfect at handling the high stresses and heat associated with the power of a jet engine. Russian metallurgy is not nearly as advanced, and they find this one of their main stumbling blocks in duplicating the engine. The Nien can run 500 hours between overhauls, but the Klimov copy doesn't last more than 100. They increase the size of the combustion chambers and turbine and refine the alloys used to create the engine. This new model is known as the Klimov VK1. With the engine ready, they can now finalize designs. In April of 1947, the Council of Ministers issue a decree ordering Mikoyan Gurevich to build 2 prototypes of a new jet fighter, one that will put the Soviet Union ahead of the field in aircraft design. The Boeing B-29 has been America's frontline bomber since the final year of World War II. It's a revolutionary leap ahead of other aircraft, with its pressurized cabin and computer-assisted gun turrets. And now that the United States has the atomic bomb, the Soviet Union needs the future capabilities to defend against a bomber entering their territory with one of these tremendous weapons. The Council of Ministers wants an interceptor for just such a situation. Mikoyan Gurevich looks back at their earlier aircraft to see any lessons they can learn. Their experimental canard plane, the MiG-8, had swept wings, a feature that they're interested in exploring further. Some captured German designs, like the TA-183 Huckebein, had swept wings implemented as well. Their latest jet, the MiG-9, has been promising, and they used this as the base to build from. Its engine troubles have been solved with the Klimov engine in place of the BMW power plant. It will also receive newly designed wings, swept back at an angle of 35 degrees. After some additional refinements, this new creation, the MiG-15, has a top speed of over 650 miles per hour. Though early production aircraft have a tendency to roll, these problems are lessened by adding aerodynamic trimmers near the ailerons and rudder. It's also recommended that pilots stay below Mach 0.9 to lessen any other stability problems. Test combat trials are conducted with a captured B-29 as well as the Soviet copy, the Tu-4. To shoot down the Superfortress, the MiG-15 is armed with two 23mm cannons and a single 37mm cannon. In 1949, production stops on the MiG-9 and the MiG-15 enters the Soviet Air Force. June the 25th, 1950. North Korean troops cross the 38th parallel into South Korean territory. By July the 5th, American forces have joined with the South Korean army. The United Nations also enters the fray under the guise of a police action. Soon, the conflict escalates beyond a ground war when the US calls for strategic bombing with its B-29s. In addition, piston-engine fighters like the Mustang and the Corsair, left over from the Second World War, are joined by the jet-powered Gloster Meteor and the F-80 Shooting Star. With the South Korean forces bolstered by UN support, North Korea also looks outside its borders for help. In October, Chairman Mao Zedong of China, fearing that a US occupation of the Korean peninsula would eventually lead to war with his country, sends a volunteer army into the fray. The North Korean and Chinese leaders ask Stalin for help, and while the Soviet dictator is unwilling to send in ground forces, he does provide aircraft in the form of the MiG-15 jet fighters, painted in Chinese colors to mask Soviet involvement. Soviet pilots are sent to train North Korean and Chinese airmen how to fly the fighter jets. They're taught simple Chinese phrases and dressed in Chinese uniforms and sent into the skies to combat and shoot down B-29s and engage the UN fighter forces. The piston-engine planes like the Mustang and the first-generation straight-winged jets are no match for the abilities of the MiG-15. It's faster, can fly higher and longer than any of its opponents. The Soviet victories come fast and often. The American pilots use their years of dogfighting experience to counter the superior technology at their enemy's disposal, but it's not always enough. Soon, B-29s are forced to limit their bombing runs to nighttime.
The first sighting of the MiG-15 in the Korean War, I think, had the same impact on pilots that as did the first sighting of the Focke-Wulf 190 just after the Battle of Britain, when it appeared in Europe. And we had nothing really to compare with it for the next year. Its success was due to two factors. One was the jet engine they had, the Nin, and the second one was, of course, the data they got from the captured German sources on the sweepback, wing sweepback. So it was a twin contribution, if you like.
Soviet air superiority begins to change in December of 1950, with the arrival of an all-new fighter aircraft for the American forces, the F-86 Sabre. First developed as the straight-winged FJ Fury jet, its design has changed to incorporate 35-degree swept-back wings and automatic slats. The Sabre is not a leap ahead of the Soviet jet, but it does level the playing field. The discovery of an advanced British engine in the fuselage of a Russian-designed plane infuriates the Americans. This is not the first time the Soviets have made a huge leap ahead in military technology. The August 1949 detonation of Russia's first atomic bomb showed just how far they could advance technologically in a few years, with some outside help. First, Klaus Fuchs, a German-born scientist brought in by England to work on the Manhattan Project, has been arrested for providing the Soviet Union with atomic bomb designs. And at the moment, Donald Maclean, a high-ranking British Foreign Ministry official, is suspected by the FBI of providing the Soviets with a variety of information. As the British representative on the American, Canadian and British Atomic Secrets Council during the war, he's had access to nuclear secrets at a time when the quest for the bomb was known only to a few. It's in the autumn that UN forces finally get their hands on the MiG-15 and discover the secret of its power plant. It's confirmed when two men are dropped behind enemy lines to a crashed MiG-15, dug into the ground. No chance to remove the entire wreck, they use grenades to separate the engine. The Americans are livid. How could England have handed over a piece of powerful technology to Stalin's regime? But they have little time to blame Sir Stafford Cripps for selling the engines to their enemies. He's been retired for close to a year due to failing health. In October, Winston Churchill's Conservatives edge out the Labour Party, knocking Attlee out of government. Churchill, as Prime Minister once more, makes Anglo-American relations a priority again. And with him back in power, there's little chance that the Soviets will find any socialists to sell them other technology. In the northwest of Korea, in an area along the Yalu River, the first large-scale jet versus jet air battles of history take place, in an area dubbed MiG Alley. When the Sabres reach MiG Alley, they have only 20 minutes of fuel to engage the enemy with. The MiG-15s, with their bases nearby, can linger much longer. American pilots charge in at 40,000 feet, only to find the MiG-15s flying 10,000 feet above them. The MiGs hide in the sun's glare, then swoop in as a formation of Sabres are on patrol. The Russian fighter does have its share of weaknesses. The cannons it's equipped with, while powerful, have a low rate of fire compared to the Sabre's guns. It also has poor stalling characteristics. A Sabre pilot can force a MiG-15 into a dive that becomes a spin that cannot be recovered from. The combat experience of the United Nations pilots ultimately trumps the sophistication of the Soviet plane. By war's end, the UN forces have shot down 900 enemy aircraft, almost 800 of which are MiG-15s. But the aircraft has proven that the Soviets can use a blend of ingenuity and craftiness to match the West's innovation. Between the USSR, Czechoslovakia, Poland and China, over 16,000 MiG-15s are produced. In 1958, Rolls-Royce Deputy Chairman Whitney Straight is touring a factory in China when he sees an engine curiously similar to the Nien. Discovering that its origins lie in the reverse engineering of the Nien, he attempts to collect payment for the almost 50,000 engines that Klimov made by taking and adapting the design and licensing it to other countries for the MiG-15 and later aircraft. £200 million is the compensation he's looking for. He leaves without one farthing. The man whose decision led to the jet engine being copied is long since gone. Sir Stafford Cripps dies in April of 1952 in the midst of the Korean War. And while he's remembered mainly for his contributions to Britain's war effort and the post-war cultural shift, he will forever be tied to the MiG-15 by that one decision.
Cripps has always been, to a large extent, the prisoner of his own reputation, but it was a reputation that shifted over time. In the 1930s, his own high principles led him to take a very extreme political position on the far left of the political spectrum, arguing that only full-blooded socialism or even communism could offer an answer to the economic problems of the day. By the 1940s, Cripps's position is quite different from what it had been 10 years previously. It took people, quite naturally, some time to catch up with the rather rapid evolution through which he'd gone.
An evolution which is often overshadowed in aviation circles by this gift to Russia. A decision that may have been motivated by all the right reasons, but strengthens the might of the Soviet military for years to come.
Air Force General Henry Harley Arnold writes in 1941, "A nation likely and able to win a war will enter it not only with the largest and most efficient air force, but behind that first line will stand the second line, the ability to maintain that superior strength in men and machines." 3 years later, the general's prophecy is now reality. On June 15, 1944, the first B-29s fly over mainland Japan. Unlike the Doolittle raid 2 years prior, this is a mission of epic proportions. That is because Boeing's Superfortress, the largest plane in the world, is designed for destruction, to grind the Japanese into a pulp, to bring them down to their knees, once and for all. With wings spreading over 140 feet, a fuselage 98 feet long, and 4 engines each possessing 2,200 horsepower, the Superfortress is the envy of the entire world. A true symbol of American industrial power. Billions of dollars, combined with the blood, sweat, and tears of its creators, make this the most feared aircraft of the Second World War. For it is a weapon that doesn't start wars, it finishes them. For all its accolades and accomplishments, the Superfortress is America's biggest gamble of the war. A design so complicated, it is the most expensive risk for the United States government. A project that at times seems doomed for failure, and a project that requires a contingency plan. What to do if it never makes it out of the factories? Where to go if the people of Boeing cannot get the job done? This is the secret history behind one of aviation's greatest bombers, and how it almost never came to be. The what-if scenarios that America is prepared to take in order to get it off the ground and win the war raging in the Pacific. This is the race for the Superfortress. Even before America is officially involved in the Second World War, the B-29 is already envisioned. The need for long-range aircraft capable of rendering a decisive blow against any potential enemy is an urgent priority for visionary generals like Hap Arnold. For the next 2.5 years, as America remains officially neutral, they are behind the scenes, making extensive plans that include a barrage of new military projects, with a long-range bomber high on the list. Not until the Japanese attack on Pearl Harbor in December of 1941 do the wheels begin to seriously move.
In the first few weeks of war, over 350 of the 525 combat planes we had in the Pacific area were destroyed. Over 1/4 of our total combat strength was lost. We suddenly found ourselves engaged in a mortal struggle with an enemy who could be counted on for nothing except bitter and fanatic opposition.
According to President Roosevelt, the United States was not particularly well prepared to engage in the war itself. In 1940, Roosevelt called for increased congressional appropriations for military spending, arguing that what the United States needed was to be producing 50,000 planes per year. In 1939, the U.S. produced fewer than 6,000 planes.
With the United States at war against both Japan and Germany, bombers are rushed into service. As one old soldier remarked, "Isn't it sad During all the years since the First World War, we've had all the time in the world, but no money. Now we have all the money in the world, but no time. In this race against the clock, America comes together. Bombers are wheeled out of assembly lines in order to wreak havoc over Germany. Of notable distinction are Boeing's Flying Fortress and Consolidated's Liberator, where in Europe, with Britain providing a base for operations, American air power is successful due to the short distance from England to Germany. On the other side of the world, the situation is very different. In the Pacific, aircraft with a greater range are needed in order to attack the heart of Japan. It is this geographical requirement that calls for the construction of a design that not only delivers tremendous firepower, but ensures that it reaches its target there and back safely. Operation Matterhorn, the secret plan to bomb the Japanese from China. Approved by President Roosevelt, it is in these pages that the urgent need for the superfortress is born.
The initial requirements, simply as I recall them, were a 5,333 mile range, and I don't know why that odd number, a 2,000-pound bomb load, and I think the speed that they specified was something like 273 miles an hour or something. Those were the basic requirements.
A unique organization, the 20th Air Force, is formed, headed personally by Hap Arnold, to see over all B-29 operations. All the military needs now is for one company to step up. Unlike the military-industrial complex of today, during the 1930s, aviation companies are hesitant to get in bed with the government to make military planes.
Companies that could easily be producing military goods, such as aircraft factories, were reluctant to convert their plants for military production because they weren't sure how long hostilities would last.
In an era of neutrality acts and cynicism towards any signs of war profiteering, only fixed price contracts are given by the United States. Under these rules, the developer must put forth their own money towards the design with no guarantee of a deal being signed. And with technology becoming more complex, signing on to the B-29 is like playing Russian roulette with your company's future. It is a large risk, one that the giants of aviation are not willing to take. As one Boeing employee said, "There was no sound of coin in Uncle Sam's jeans. His pockets only carried marbles and chalk." With most manufacturers losing money during this period, few were willing to step up to the plate.
The military production in which U.S. workers were engaged in 1940 and 41 as part of the effort to support the Allied forces helped to pull the United States out of the Depression. Lots of people were back to work, and what that meant was that they had disposable income. Many manufacturing firms did not want to convert to military production because they were eager to take advantage of that consumer dollar that was now available.
Douglas, a rare company to turn a profit during the Great Depression, is avoiding the superbomber project like the plague. After having their arms bent by the government to develop the B-19, they reported losses of more than $2 million. Not wanting to be fooled again, their submission for the contract is nothing more than a slightly modified version of that same bomber. In government circles, there is great concern. If Douglas is only putting forth a minimal effort, it is apparent that they are not interested. Lockheed, another manufacturer, is still a young company and a question mark at best. Boeing, having lost money on the B-17, would have gone bankrupt had the government not bailed them out in 1940. With only 2,000 employees, they, like others, want to stick with what is known and proven, instead of venturing out into the uncertain. Surprisingly, they submit their design, and it is accepted.
Boeing had a tremendous reputation on the basis of the B-17. And when you think about the Pacific now, it would have been impossible for B-17s and B-24s to fly those distances in the Pacific.
And so the makers of the Flying Fortress begin the project in haste, starting work on a plane that is built before it is even designed.
You would always like to build a prototype airplane and fly it and work the bugs out before you commit production of the airplane. In this case, the Air Corps made it known at the very onset of the program that they were going to buy production quantities of airplanes before the prototype ever flew.
Certain sections of the aircraft are constructed before detailed designs of other parts are even sketched out. They begin a long and painful journey to build one of the greatest airplanes ever. Boeing decides that the B-29 central nervous system is to be based in America's heartland, Wichita, Kansas. A small city of just 120,000 people is chosen as the site where the Superfortress is to be built.
Why Wichita specifically? There are a couple of reasons for this. If you look at a map of the United States, you'll see that Wichita is just about in the dead center of the country. Also, unlike some other cities in the state like Kansas City, Wichita had a very tiny proportion of foreign-born residents. Some government officials were concerned that immigrant workers would be more inclined to participate in labor agitation, might be more inclined to come from a socialist or communist tradition, or in some cases might be allied with Nazism.
Hundreds of miles away from America's vulnerable coasts, and a farming population familiar with machinery requiring less money to live on, Wichita is ideal for Boeing. Expansion is a necessity, and the city is eager to accommodate both the government and Boeing during the war years.
The Great Plains region mobilized to lobby to bring industry to their area. The state of Kansas organized an Industrial Development Commission in 1939, and in fact, the governor of Kansas went to Washington, D.C. to lobby on behalf of his state, arguing that Kansas was safe from invasion. It had lots of natural resources, such as oil, gas, and coal, and it had a large supply of pragmatic farm boys.
And so begins an assembly line of epic proportions. A similar system that Henry Ford used to make Model Ts in Detroit, Boeing is using to make Superfortresses in Wichita. Grandmothers, who never wrestled with anything more intricate than a wood stove up until 2 years ago, are building Superfortresses at Wichita. What is true at Wichita probably applies equally to other major production units of the B-29 program. The Superfortress truly can be said to be a product, as President Lincoln said, of their government. That is, of, by, and for the American people. Quoted from the New York Times. With a small army of workers, over 60% of the aircraft is fabricated on the spot. Unfortunately, one plant cannot do the job alone. The outsourcing of the B-29's many parts are done in cities such as Marietta, Georgia, Omaha, Nebraska, and the home of Boeing, Renton, Washington.
There were something like 764 airplanes on order before the B-29 ever flew. Those airplanes were going to be built by 3 companies in 4 plants. Boeing was going to build the airplane in Wichita and Seattle, the Renton plant, Bell in Omaha, and Martin in Marietta, Georgia. So production was committed before the airplane ever flew, and it was a high-risk program, recognized as a high-risk program from the very beginning.
It is a project coming from every corner of the country, a true testament of America's industrial strength during the Second World War. As the B-29 is constructed, one notices that it is not revolutionary but evolutionary. A true sign of the times, with militaries thinking bigger is truly better. At the beginning of American war production, the average aircraft weight is estimated to be just over 3,000 pounds. 4 years later, that average is shot up to over 10,000 pounds. With this plane's massive size and potential, it comes as no shock that its supporters are eager to get up in the air as soon as possible. Although the enthusiasm for the B-29 is strong, the call for a plane of this magnitude is easier said than done. Being twice the size of the B-17 and requiring double the horsepower, completing it is no easy task.
It was a big jump from, let's say, the B-17 for people who were in the 17 that went to the 29, and it was one very big jump for us who went from the B-25 to the B-29. It was monstrous.
You had tremendous power in 4 engines compared to the B-17. And I flew the B-29 up to 40,000 feet, whereas the B-17 would barely go to 30,000.
Before being put into production, 10,000 drawings are sketched of a prototype, costing the government over $3 million. With it needing to be rushed only adds to its growing list of future problems. Its main flaw is its complexity. With a need to fly at extremely high altitudes, a pressurized cabin is desired, so its crew are not required to wear masks in the air.
It was the first pressurized airplane, one that I'd ever flown. I think it was the first thing after the B-17, the B-24 that came along that had a pressurized cockpit, which made flying at altitude far more comfortable than unpressurized, of course.
You kept your oxygen mask handy just in case you lost your pressurization. But it was very comfortable. It was a big relief, much easing of strenuous activity on the part of the whole crew.
Also, with 4 extremely powerful engines and over 60,000 different pieces needed to assemble just one plane, this project is turning into one giant jigsaw puzzle.
So the airplane that got submitted had grown from an 85,000-pound airplane to something around 110 or 111,000 pounds.
In addition, an enormous amount of material needed. 27,000 pounds of aluminum, 5,000 pounds of rubber, 10 miles of wiring, over 1,000 pounds of copper and brass, and nearly 2 miles of tubing are needed to make this monster. To some, this is becoming a case of the United States biting off more than it can chew. Despite the best efforts of its designers, engineers, and workers, the B-29 is encountering numerous problems. For a population of 120,000, putting together a 120,000-pound superfortress is a massive undertaking due to its workforce's relative inexperience. Recruited from the ranches and farms of the Great Plains, these men, and now women, have not been properly trained for a task of this magnitude. What normally takes years to learn, they must master in just months. While in flight, as is the case with Lockheed's Constellation, overheating is becoming the norm.
Some of the engine problems that were there were things like overheating of the engines. Early on, we had problems, again, with propellers that would overspeed, wouldn't govern properly, wouldn't feather properly. We had problems with the carburetors. The engines would backfire.
During one test flight, a B-29 crashes, killing the entire crew, including Eddie Allen, Boeing's chief test pilot. Despite these deaths and setbacks, the project must continue. For America's top generals, the B-29 is becoming a race against the clock. With air bases being built in China, the expected arrival of the superfortresses is scheduled for April of 1944.
I understand, because of an agreement between Roosevelt and Chiang Kai-shek, that these airplanes were going to be in China a year before they were. So the rush would get them out of the country.
The crew at Boeing, however, is nowhere near completion. Despite this harsh reality, one man, General Hap Arnold, does not throw in the towel. Writing to fellow General Curtis LeMay, he proclaims, "The B-29 project is important to me because I am convinced that it is vital to the future of the Army Air Forces. more concerning are the project's economic costs. By the end of development, testing, and production, the government is estimated to have spent over $3 billion on the Superfortress, a third more than what is spent on developing the atomic bomb. For these generals, it is not only militarily vital that the B-29 succeed. Financially, if the model fails, billions will be lost.
Well, when I got to Wichita, I found out they weren't flying them because the Boeing company had taken this position that the airplane was no good and they weren't going to make them. I understand, secondhand or third, that General Arnold told Boeing officials, you're going to build that airplane or give us back $50 million we've already advanced for its being. They thought real quick. They said, well, we'll build the airplane, but we won't take any responsibility for it. Arnold is reported to have said, you don't have to take it. The Army Air Corps will take that responsibility.
These ongoing problems become crystal clear in March of 1944. Hap Arnold, on an inspection mission, asks how many are ready for shipment to India. Due to the complications in its design, he is shocked when Boeing's answer is 0. It is for this reason there lies an insurance policy, a backup, a contingency plan in case Boeing fails. And for this possible savior, the American government goes to the other 3 giants of aviation, companies that designed their own version of the Superfortress. The B-30, 31, and 32 can hopefully come to the rescue if all else fails. At least, that is what the government hopes. Lockheed, with their B-30, represents only a token effort. Many are unsure if they can carry through on a project of this magnitude. The plan to make their Superfortress a gigantic bomber version of the Constellation goes nowhere. Their main priority is given to the Connie, which makes it up into the air nearly a year and a half before the B-29 does. The situation is identical at Douglas. Their B-31 design never sees the light of day. Of its 3 competitors, only one gets a plane up in the sky. Consolidated, makers of the B-24 Liberator. They, like Boeing, are commissioned to evolve their design with the B-32, known as the Dominator. Weighing 50 tons, possessing a speed of over 300 miles per hour, and containing 4 2,200 horsepower engines, the aircraft appears to be a carbon copy of the Superfortress.
The B-32 was an outgrowth of the B-24, like the B-29 was an outgrowth of the B-17.
And just like the B-29, the Dominator suffers from the same technical problems. The program is almost canceled in December of 1944 due to development being severely behind schedule. By the end of the war, only a handful of B-32s fly over the Pacific, conducting mainly reconnaissance missions.
The B-32, I had one there at Bomber Test. I flew it. It had no distinctive advantage over the B-29. Matter of fact, I had to order my test pilots to fly it. They didn't much care about flying it.
The key advantage for Boeing is its will and determination. With countless man and woman hours put into this project, combined with billions of dollars in funding, they are determined to complete it no matter what the cost. Being so far along with its development, they must see it through.
The aircraft plants in Wichita adopted suggestion systems where workers could offer suggestions for how to improve efficiency and productivity and actually get cash awards if their ideas were selected by management and then implemented. Many of the amenities that employers offered to workers, like cafeterias, in some cases childcare centers, and so forth, were specifically designed to improve productivity and decrease absenteeism rates.
War production is the foundation of our war effort. And by the same token, what you do from day to day affects your country's success in this war. Never forget, you are working for him, for the youth of America, for the boy next door. On the last day of the last war, thousands of such boys were killed. If the war had ended 24 hours earlier, they would have returned. What you do tomorrow, today, in the next hour, can help to bring the last day of this war closer and to save lives that would otherwise be lost. We are all in this together. You and I, your own boy, and the boy next door. Our job is not finished. Let's finish the job together.
With a gun to their heads, the people of Kansas come together and begin rolling superfortress after superfortress off the assembly line.
In the essence of wartime conditions, you overcame absolutely any obstacles. It may have taken only 1/10 the time that it would take to solve a technical problem in peacetime. But under wartime conditions, you know, if you can't solve it with 10 engineers, get 100, and that's what the contractor did.
When Arnold, in a fit of rage, demands that 175 B-29s be on time for delivery, this almost impossible task is miraculously accomplished by the people at Boeing, Wichita. Working around the clock for 4 straight weeks, 600 workers meet this goal. Compared to a grand total of just 4 in August of 1943, by February of 1945, Boeing Wichita produces 100 B-29s per month. With 20,000 man-hours, these workers are able to produce 4.2 superfortresses a day, a shining example of both their patriotism and dedication. Until the end of the war, production is right on target. On June 5th, 1944, from an Indian airbase, the first B-29s take to the sky. It has been a strenuous journey, as the aircraft has traveled more than half the world to reach its target. 10 days later, under the 20th Bomber Command, headed by Hap Arnold, 47 superfortresses depart from Chengdu, China, and begin bombing Japan mercilessly. For the next year, the B-29 becomes the primary tool of destruction in the Pacific. With the Japanese already in a weakened state, they simply cannot compete with this advanced superbomber. Things only get worse as the Americans capture the Mariana Islands. With a shorter range to Tokyo, these strategic outposts do nothing but accelerate B-29 activity over the land of the rising sun. Day after day, Japan is bombed into submission. Led by General Curtis LeMay, his strategy of bomb them and burn them is proving effective. Cities the size of New York, Cleveland, and Pittsburgh are being decimated. LeMay even remarks that by mid-1945, they are going to run out of targets to bomb. That dilemma is solved on August 6, 1945. A B-29, the Enola Gay, flies over Hiroshima, Japan, carrying an atomic bomb on board. The order to go nuclear is given by President Harry Truman. The effect of this new weapon forever changes the way wars can now be fought. The results are devastating. An estimated 80,000 people are killed from the first atomic bomb.
I had seen the city perfectly visible as a place where a lot of humans were moving about. If you could see it, you see movement. But when I flew back by it and I was out the co-pilot's window, I look at it, all I saw was something that reminded me of a boiling pot of tar.
3 days later, another superfortress, Boxcar, drops a second atomic bomb on the city of Nagasaki, killing tens of thousands more. These 2 attacks, in addition to the Soviet Union's declaration of war against Japan, finally causes this once proud nation to surrender unconditionally.
Aboard the USS Missouri in Tokyo Bay, on Sunday, September the 2nd, 1945, the most horrible war in history came to its complete and formal end. Foreign Minister Shigemitsu signed for Japan. Douglas MacArthur, Supreme Commander.
The B-29, with its years of development and construction, proves its worth to the American military. For it is truly the bomber that made the difference.
It's my personal opinion, and I'm sure I'll find detractors, that the B-29 won the war, World War II, in the Pacific.
Oh, I think without a doubt, when you consider particularly the Pacific War, it was a key point in winning it.
And so the people of Wichita, the people of Marietta, the people of Omaha, and the dozens of other towns and cities that contributed to its production go back to their regular lives. Boeing, with no more orders from the government, lays off 70,000 workers at the end of the war. The service they have done for their country, however, does not go unnoticed.
I think historians would argue that war production in the United States was pivotal, if not decisive, in the war effort overall. The United States, over the course of the war, spent more than $50 billion on Lend-Lease aid to the Allies. By 1944, U.S. factories were producing a ship a day and a plane every 5 minutes. But that's a phenomenal amount of production.
In the B-29's history, the men and women in these plants are just as important as Hap Arnold, Curtis LeMay, and those piloting the aircraft.
It's a joint effort of everyone. The maintenance, the supply, everyone contributed to it.
For a 3-year period, of the over 3,000 Superfortresses built, 1,600 of them come out of Wichita alone. On August 29th, in a statement to Boeing employees, General Arnold proclaims, "Thanks to what you did, our combat crews had been trained and B-29s were ready and waiting to occupy Iwo Jima, Saipan, and Okinawa as each base was prepared to receive them. You were given a job to do, and the way you finished that job met our greatest expectations. For myself, and on behalf of the Army Air Forces, I say to you, well done, and thanks from the bottom of my heart." The Superfortress should be remembered as the greatest roll of the dice in American aviation history. In an era where aircraft manufacturers had little to gain with costly military projects, it is amazing that it was able to get into the skies as quickly and efficiently as it did. The race for the Superfortress is also truly an American story. Its industrial capacity and strength, a supply line uninterrupted from bombings and destruction, and a diligent and patriotic workforce is what made the B-29 possible.